Let a sub n be a non-constant arithmetic progression. The first term is 1, and the following holds true. For any n greater or equal to 1, the value of a sub 2n all the way up to a sub n plus 1 over a sub n all the way up to a sub 1 remains constant. Or, in other words, it means the value does not depend on n. Find a sub 15. Since the value of this fraction is a constant, we can give it a name. Let's call it c. c is equal to, now it seems like the top and the bottom is basically just a1 all the way added up to a2 sub 2n split into two parts. The first part is from a sub 1 to an. The second part is from a sub n plus 1 to a sub 2n. We know how to find the sum of a sequence. So in order to be able to utilize what we know, we need to construct an expression that will make our knowledge applicable. So let's add 1 to both sides. The left side becomes c plus 1, and the right side, we're going to make it a sub 1 added all the way up to a sub n on the top and bottom. Now, since both fractions have the same denominator, we can combine them. On the top, we're left with the sum of the first two n terms. So we can denote it as s sub 2n. And the bottom is s sub n, the sum of the first n terms. Because we know that c is constant, c plus 1 is also constant. Therefore, the value of this fraction must not depend on n. So how can we express the sum of the first two n terms and the sum of the first n terms? Well, we know that a1 is 1. And if we go all the way up to an, that is equal to the first term plus n minus 1 amount of common differences. And when we go all the way up to a sub 2n, that is equal to the first term plus a 2n minus 1 amount of common differences. And the sum of the first two n terms will be equal to the first and the last term times the total number of terms, which is 2n, over 2. And the sum of the first n terms will be equal to the first term plus last term times the total number of terms over 2. Now we just have to divide these two expressions. This would be equal to 2 plus 2d times 2n minus 1 over 2 plus d times n minus 1. Now let's go ahead and call this another constant, r. We can give it a name. Now, only focusing on this part of the equation, let's multiply the denominator on both sides. We can combine some terms and move some terms around. So we're left with the right side of the equation can be factored further. And we're left with this equation. And because r is a constant, this equation must hold true for any n. Now, let's first suppose that both sides are non-zero. What would happen? Well, as n changes, the left side will also change with it. But the right side will always be a constant. This means that the equation will be unequal at some point. The equation will not hold true at some point. But this equation must hold true for any n, which means that the only situation where this will happen is when both sides of the equation is equal to 0. So how can the left side be 0? Well, n and d cannot be equal to 0 because we're talking about a non-constant arithmetic progression here. It means the common difference cannot be equal to 0, which means that r must be the one equal to 2. That way, it can make the left side 0. So then we're left with 0 is equal to 1 times d minus 2. Clearly, the right side also has to be 0. So d is also equal to 2. Now we have found the common difference for the arithmetic progression. It means we can also find the 15th term. The 15th term is equal to the first term, 1, plus 15 minus 1 amount of the common difference, which is equal to 1 plus 14 times 2, which is equal to 29. So the 15th term is equal to 29.